Let's go ahead and get started. Thank you everyone for coming. This will be a little different. I usually have slides when presenting. Today it's just me and an IDE, so this will be nice and dangerous. My name's Larry Garfield. You may know me online as Crell. If you want to make fun of me during the session on Twitter, that's where you do so. I highly encourage it. I'm a senior architect with Palantir.net. Where's the rest of my Palantirian here? So we're a web consultancy based here in Chicago. We do end-to-end strategy, design, development, site architecture, theming, pretty much everything except hosting we'll do. And we can work with most hosting partners as well. We are primarily Drupal, but not exclusively. And today we're actually going to be talking about another tool that we have used once or twice called Silex. Who has heard of Silex? Good. Who has used Silex before? Who's used Drupal before? Who's used Drupal 8? Yeah, decent number of people, all right then. Who's used Symfony? Okay, so none of you are actually going to get anything out of the session because you all know what I'm talking about. But we'll plow ahead anyway. So, what is Silex? Silex, if you read the description for this session, is a microframework. What is a microframework? Does that mean it is small? Well, no. Microframework means that it is small in terms of the number of assumptions it makes. Think small core, which had nothing to do with the number of modules in core. It had to do with the decoupling of things. A PHP microframework is one that makes a few assumptions for you. It provides basic functionality and gets out of your way. Silex is a microframework built primarily on Symfony components. That means it is its own system, but is essentially a cousin of Silex, it's a cousin of Symfony, and a cousin of Drupal 8, and of anything else built on the Symfony components. So a lot of the stuff we'll be talking about here applies conceptually to Drupal 8 and Symfony and various others as well. Silex itself is built out of the main Symfony components, and it's a dependency injection container called Pimple. We'll see more about that shortly. And I guess let's actually just dive in and start building stuff with Silex. So Silex, like most modern tools, you install via Composer. There's no starter kit by default. There are people who have built starter kits. I'm just going to go from the vanilla Silex package on Composer. And so we have a composer.json file that says require Silex, version 1.2. It's the current stable. And we run composer install, and we get our library. And then we can set up our index file, in which we include our autoloader because it's a composer project. That's how we always start. And then we create a new Silex application and run it. Congratulations, we have now built a Silex application. Let's see what this does for us. This is it.
Short presentation.
Yes. And it gives us an error message.
Oh.
This is great. The most important thing a framework can do is give you error messages, because that means it's taking care of the edge cases for you. In this case, we have not provided it with any routes or any content or anything to do. Therefore, it knows, hey, you asked for something I don't get, and gives an HTTP 404 error. So this is good. We're starting from a good place, error messages. So let's take this and add a little bit to it to add your basic hello world route. Keep going. So this app object here is the central point of all of Silex. It is really the only object you need to interact with in Silex directly, for the most part. It is itself the dependency injection container, Pimple. It's a super simple container, and also wires in all of Symfony's routing support and routing capabilities and events and so forth. And then provides some fairly straightforward utilities to manipulate it. In this case, you can call app-get, which is the shorthand for I'm going to create a route at this path. I only want it to respond to GET requests, so a post or a put or whatever will get ignored. And this is the controller for it, which can be any PHP callable. PHP callable is a function name, a closure, an array that contains a class name and a method name, or an object and a method name. Pretty much anything that in PHP you can put parentheses after and it doesn't break, that's a callable. And so we're just going to inline our controller and return an instance of the Symfony response object, which says, this is a super simple message or messaging system. So the font is unfortunately a bit, the screen's a bit smaller than I'm used to here. So great. We get a request in, and we're going to return a response. That's what everything on the web is. Request in, response out. That's how Symfony works, that's how Silex works, that's how Drupal 8 works. And now, when we go to that page in our browser, we should get, if I can type correctly, there's our response. This is a super simple messaging service. If we looked at the source code for this, there would be no wrapping HTML. It's just that string, and that's it. We've returned a response object. We have complete control over what the output is going to be. Again, same is true in Drupal, same is true in Drupal 8, same is true in Symfony. If we wanted to respond to different types of requests here, there's also app post, app put, app delete for each type of HTTP message. And you can also do app match if you want to match all of them. In practice, I generally find it much easier to respond to a single method because I'm going to want to do different things anyway, so I might as well put them in separate controllers. Okay, so now let's do something with actual real code. So let's create a service. If I say create a service, do people know what I'm talking about? About half the room? Okay. A service in pretty much any modern PHP system is a freestanding object that does stuff. That's nice and descriptive. It's an object that provides functionality that is stateless, and therefore you can usually only have one of. It's not a singleton, but you're only going to bother creating one of them most of the time because you don't need to do any more than that. So in this case, let's actually look at what our service looks like. We're going to create a class called rot encode that, is everyone familiar with rot 13 encoding? Okay, so rot encoding is you take every character and just rotate it around the alphabet some number of times. So rot 1 is any A you replace with B, B you replace with C, and so on. Rot 2 is A becomes C, B becomes D, and so forth. That means rot 13 encoding is reversible, which makes it the second worst encoding system in the universe, encryption system in the universe. Please never actually use it as anything other than a joke or a demo. In this case, we have a class that we can configure, but just by passing to its constructor what our count number is going to be. And then when we call rot on it, it will just encrypt our string with that rot system. Ignore what this code actually is. I pulled it off of the php.net documentation. It was in a comment somewhere. That's irrelevant for our purposes. It's just logic here in an object. And because this object is nice and clean, we can dependency inject it. We can unit test it very easily, all that good stuff. When we go back to our index file, you can see here, we've got these brackets on the app object. What's that? You can't put brackets on objects. Yes, you can. It's called the PHP array access interface, which lets you hook into the engine and say, this is an object, but I want to use it like an array. I want to be able to put brackets on it. This is part of the Pimple dependency injection container. We are here going to say the rot encode count property has a value of 13, and this rot encode service name is going to be whatever gets returned from this anonymous function, this closure. This is Pimple syntax here that is just getting inherited. So when you ask for rotten code, when you try to read that rotten code, yes, the pun is deliberate, that rotten code service, this closure gets called, and whatever it is you have in here will return something. Entirely up to you what that is. It's just code. In this case, I'm just going to instantiate that rotten code class we just created and pass as its constructor that value. Who's worked with closures before in PHP? 5.3 and later? Not everybody. OK. So PHP 5.3 and later lets you define anonymous functions. So it's just a function literal, essentially, in place. So here we have a function that has no name, but we can then pass it around as any other callable, just like we could pass an object and a method name together, or a function name. And so we're going to have no parameters to it, but we're going to steal a reference to this app object so we can call it later. So when this controller gets called, it's also going to steal a reference to that app object, that global God object, and access that service. When that happens, then Silex will call this code, create a new instance of this class by first accessing that property, and then we return this object. And this app share thing says, and cache it so that the next time I call it, I just get the same object back. Everyone with me? OK. So now, when we go to about, we send that same string through that rot method we saw before and get a string back in return. And we should see that's the rot13 encoded version of that string. If you feel like verifying it, go ahead, or you can take my word for it. Note also, I'm just returning a string here, not a response object. In Silex, if you return a string from the controller, it will just wrap it up into a response. Drupal 7 was much the same. If you return a string instead of a render array, it would work. Drupal 8 doesn't actually let you do that. So, sorry. Questions? Everyone still with me?
Yeah, did you go back over the share method?
Share method. So, what Pimple does by default, it's this terrible name for a container, I agree, but that's what it's called, is if the service name you call is a callable, it will call it. And whatever comes back from that callable is what it will return. App share is really just a little utility that wraps that callable and statically caches whatever comes back. So that if I didn't do app share, if I just assigned it straight to this anonymous function, and then I call rotten code 17 times, I get 17 different instances of that object, or instances of that class. Wrapping it in app share, it'll cache it the first time, and then I'll only get that one instance back every other time, which the vast majority of time is what you want, and actually more recent versions of Pimple, that's the default. They switch the syntax around, so it'll share by default, and there's another method you call to tell it not to. OK. So now we've got an app. We can return responses. We can register services, so we have a place to put our code. Note our code is not bound to Silex in any way. This is good. That's true no matter what framework you're using. But we do want to persist data somewhere. So let's stick in an SQL, and let's use doctrine for it. Why do I say doctrine? Because it's easy for me to show off. One important point here, I said Silex is a microframework. It's few assumptions. That also means, whereas in Drupal there's a Drupal way of doing things, and in Symfony there's a Symfony way of doing things, Silex doesn't really have a canonical way you are supposed to structure your application. It is up to you to decide what that's going to be. So what I'm showing you here is basically Silex Crell edition. If you talk to other Silex developers, they may structure their applications differently. I'm telling you the way that I found works well for us. So, oops, did I miss one? Come on, close. So now, let's look at this new piece, app register. what if you want to package up one of these services and not have to wire it in yourself? You just want to provide that. For that, you have something called a service provider. A service provider is simply a class that has a method on it that will stick stuff onto the app object. That's basically all it is. And Silex ships with a bunch of them. The one we're going to use here is the Doctrine service provider. Doctrine, for those not familiar with it, is a PHP database abstraction layer. Think DBTNG, but not tied to Drupal. It's the basic idea. And so we're going to register that service provider object and give it a bunch of options to say, all right, we're going to use SQLite, and this is the file I want to use for the database. And then that will, basically that service provider contains a bunch of these kind of lines. And then I'm going to add another route that just has a bunch of Doctrine code in it that creates our database schema. Footnote, please don't ever do this. I'm only doing this for demo purposes because it's easy to show off. Okay, good. We've got our database installed. We've created our database tables. Again, please don't put that actually in a publicly routable path, especially one without access control. Please? Please? Okay. So we've got a simple route. We've got a service provider registered. We've got a custom service. And incidentally, service providers like this is actually what Drupal 8 does too. We have the syntax is a little bit different, but it's the same basic idea. If a module wants to register services in Drupal 8, or it can use YAML if it wants to modify someone else's. And then we run, and we're still not doing anything really useful, and yet we're already up to 60 lines of code. So by the time we get a really useful application here, we're probably going to end up with a couple thousand lines in one big file. Who thinks a couple thousand lines of code in one big file is a good way to structure an application? The first time I gave this talk, Angie Byron raised her hand.
Like WordPress users.
Yeah, actually, there were WordPress users in the room, but only Angie Byron raised her hand. Mostly because no one else was. So, how do we structure this better in a more maintainable fashion? There's a couple of different popular ways of doing that. The approach that I generally recommend is let's create our own application class that extends Silex's and do a bunch of stuff on our own. We just push our initialization code over here. And I like to wire it up, just break it up into a couple of separate methods like this because I find it convenient. And also because I can then pass the application object through, and I don't need to play around with binding a closure to this, because if we pass this to a closure like here, PHP gets very confused and angry. So doing this means PHP doesn't get angry. So this is just the exact same code we saw before, really. We've got our application. We're going to set our encoding count, set our service, register any providers. We're going to create a bunch of routes. All they did was move some code around. Nothing's actually changed, it just moved code around. But it does mean that our index file is now back to being nice and simple. I'm also going to just turn on some debugging information because, well, debugging is useful. And this is just a property we can then check elsewhere in our code if we want to. So, if we go back to that application though, what's the next thing we want to fix? That we want to figure out how to structure? Well, maybe the fact that we're hard coding a database name. Now with SQLite, it's not that big of a deal, but if we're actually using MySQL or Postgres or Mongo, then you'd be putting your database credentials straight into your code. Who thinks this is a good idea? Good. So how do we take care of that? Well, we can add a config file. Silex does not support config files out of the box. It's a microframework. But don't worry, there are add-ons to do that, fairly standard ones. All right. This is a third-party in the sense that it doesn't ship with Silex itself out of the box, but the maintainer for it, Igor W, is one of the maintainers of Silex. So you can just pull this in with Composer, and it's just another service provider. Works the exact same way. We go ahead and register it. Because we're using Composer, we don't need to worry about auto-loading. It'll just get picked up. And we tell it, all right, where is the config file that you should load? And we're going to load in one called settings.json that's in a config directory. And then we're going to load in one that is based on the name of this environment property, which doesn't exist yet. We haven't defined it. We're going to define that in settings.json. Why am I using JSON here? Because I like JSON, really. The config provider will support JSON files, PHP files, YAML files, I think one or two others. I like using JSON because A, it's not executable, and B, it parses faster than YAML does. And there's no caching because, well, we haven't written any caching. If you wanted to use YAML and then write some caching, okay, more power to you. I like using JSON. It makes my life easier. So let's look at those files. So we're going to start with settings.json, and it's just a JSON file, and all the config service provider will do is take these properties and dump them into the container as more properties on the big app object. So in this case, it's going to say our database path is appdb, our route encode count is 26, which incidentally is the worst encryption system in the universe, but is considered a valid form of encryption under the DMCA. So reading the text you're about to see is a violation of the DMCA. The security expert in the room finds that amusing. And we set our environment to dev. This is the file we would never check into our Git repository, but because we include two config files, we'll then load either dev.json or prod.json, or whatever else we set it to, and those we can. So like in dev mode, we'll force debug to true. In prod mode, we'll set debug to false. And otherwise, configs can be the same. Cool? And then in the, there we go. Then down here in the configuration, we just grab that value out of the container and use that. Again, this is SQLite, so there's not much to say. If it were MySQL, there'd be a user and password and database name and whatever else. Good? Okay. Now let's try, we've still got this service of our own up here somewhere. Where'd it go? Yeah, we're still registering our own service here. Is there a way we can write our own service provider? Why, yes, there is. Let's do that. So we've got no more custom services. Instead, we've now moved this we've created this route service provider class, which is totally simple. There's an interface, you implement it. Under register, you do exactly the same thing we just did. We just bundled that code off into a separate place. And there's also a boot method that we're not using. The difference is all of the register methods get called first, and then all of the boot methods. That way, if you have services that you cannot register unless you know some other service, you get a second pass. That's actually not that common because this won't actually get called when building the container. It'll only grab that when this gets called in the first place, which generally won't be until long after you've already finished building all of these things. Yes?
So boot is for bootstrap, not like boot as an init? Because it requires dependencies?
Kind of. Boot is what you would use if the definition of your services themselves are going to depend on some other service,
Okay.
which is usually a bad idea in the first place,
Right.
but if you need to do that, that's where you would do it.
Why doesn't register need to return anything?
Register does not need to return anything because PHP passes objects by handle. So we're just calling methods and setting stuff on this app object. It's basically an alter hook. think of it the same way. But because it's an object, you don't need to pass it by reference. Okay, so now we've got a nice place to register additional services to glue our code into it. How about routes? Can we move those out? We can do that too. Let me do it at a time. Come on. Those work essentially the same way. You've got a class that implements controller provider interface, which has one method, connect. And this is a little bit different. You actually have to grab the controller's factory service, call those same methods we saw before on that, and then return that. Why do you have to do this differently? I couldn't actually tell you. It doesn't make any sense to me. I hope they fix it in later versions of Silex. But if we go back to our application class now, we've added another method, create routes. So register providers, we're now just creating that provider. And then under routes, we're going to say mount and give it the name of the provider class. And we can also put a prefix on it, in which case every route in that provider gets that prefix. So if we wanted to put slash MidCamp here, then the route, the about route here would get registered as slash MidCamp slash about. And honestly, I rarely use that. Another thing to note here, I'm structuring code with separate service providers inside this rot subnamespace. This lets me have effectively a kind of module just for each namespace. I like to do that to help keep my code nicely segregated. The last project we built had back like 8 pseudo quasi-module-like things there?
Maybe more than that.
Maybe more than that. So break your code up logically. It means that if you want to, you can then take any of those namespace directories and just break them off to a separate composer library and everything's fine. Again, that's Silex a la Crell, not necessarily the way everybody does it, because there is no way that everybody does things in Silex. Okay. So now we know the basics. How do we do something actually useful? So when you're doing demoing a new web framework, generally speaking, your demo application is a blog. And when you are demoing a REST system, federal law requires that your demo system be a Twitter clone. So let's implement Twitter. What do we need for Twitter? We need users and messages. So we need a way over REST to create and edit users and post messages. So let's do that. So, given what we've just learned about good ways to structure an application, let's create this new users module-ish like thing. And let's start with a user repository. User repository simply means class from which we load user objects. And this is just pretty basic. We take a Doctrine database connection and run some SQL. I'm not going to get into how Doctrine works. You can learn that separately on your own if you want. But it's dependency injected. We've got a find by ID, a find by username, an update, and a create. Okay. Now how do we get that into the system? With a user service provider, which, just like we saw before, we create a service called users.repository, module.meaningful-name, basically. And that service is going to return an instance of that user repository object. And we're going to give it that one additional service, which is the database connection from Doctrine. And then we're going to create a bunch of controllers. We're going to have a couple here. So standard REST pattern. If we post to /users, then we can post a JSON object that is a new user, and we'll grab that content out of the request and decode it, create a user, and then generate a URL. How do we know what URL is going to be? This is the same mechanism that's in Drupal 8. A route can have a name. So let's actually look at this user's route, individual user route. We're going to create a route called users/curly braces user. That's how you mark a placeholder. And then that controller gets a parameter called $user. And whatever gets passed in here will get passed here. So if you go to /users/12, 12 gets passed in here. It matches up by name, not by position. So if you have multiple of them, multiple placeholders, they've got unique names, it'll all match up. The order does not matter. That's exactly the same in Drupal 8. And then we're going to give it an actual machine name for that route so that we can reference it from elsewhere. If we don't provide one, Silex will generate one internally that makes no sense to any human being. So now since we have this route, we can reference by name, we're going to grab this generator service and generate a link to users.view with a parameter, if we can see it, of whatever the username was that was just posted. Okay? Exact same logic you follow in Drupal 8. And then we send app redirect, which creates a redirect response, which then will redirect the user. And we're going to say it's a 201. So you post a JSON object to /users. It creates a user object. It sends back an HTTP 201 saying, hey, cool, I created that object. Here's where you go to get it. It's whatever that URL is. Your REST client then goes to that URL and says user/1 to whatever. Actually, in username, I'm sorry. We load by username, strip off the ID because in REST you're not supposed to know internal IDs, render it to JSON, and return a JSON response that has all the headers set up, and that array has been rendered to JSON, and you're good to go. That's a bit much. Yes?
You say that's exactly the way it works in Drupal 8. What part of Drupal 8 are you talking about?
In the Drupal 8 routing system, you define routes. The syntax is a little different. You're using YAML for it, but they've got a machine name. They use that same syntax with curly braces. Anything in that curly brace matches up by name to your controller. And if you are generating a link in Drupal 8, you do not write a path. You use a generator service and link to it by the machine name with placeholders. So the syntax is a little bit different, but logically everything I just said is exactly the same in Drupal 8 and in Symfony 2 and Silex and a couple of others.
It would be great to see more code examples of that.
In Drupal 8, I don't have those.
I know, but maybe it's like comments to this talk or something like that.
So let's actually try this. I'm going to post to the user's path with drum roll, please. Do it right. I broke it. Nope. Nope, I didn't. Here we go. HTTP 201, which means created, and location /users/Crell. So let's get /users/Crell, and there we go. There's me. Yay! Simple, right? Ish. Once you get into the pattern, that took like 5 minutes for me to write, maybe 10 minutes. A few other notes before we move on there. That's so we're now routing that other provider we just created. And We're also registering that service provider we just created. And oh yeah, the generator service. That's provided by Silex, but it's not actually enabled until you enable it. You have to enable everything you're going to use. Pretty much nothing except routing itself is there by default. Okay, but if we look at that, that user controller, do we really want all of our controllers to be defined as anonymous functions in one giant method?
No.
No, we do not. Even Angie agreed on that one. So now, can we break that up better? Turns out we can. Again, a couple of different ways to do this. This is the way I like doing it. Oops. You can, in fact, register controllers as services. So let's create a new class, user controller, and it's going to be a service, so we could inject into it just the services we actually need. However, you could also just inject the container itself, the whole application, and have access to all services. Which is the better way of doing it? In the individual ones, you said ladder, the whole thing? Generally speaking, you don't want to inject the container anywhere. Your code should never ever know about the container. Controllers are arguably an exception to that because they should not have any code in them worth testing. Your controllers should be simple and stupid. Your actual logic belongs in services, and your controllers are just glue code to bring them together. The last Silex project I did, we did do full dependency injection of services for controllers, and it ended up making things a little more difficult than they needed to be. So I now recommend just inject the application and put a very strong limit on what you're allowed to do in a controller. So we're just going to move all of this code from that provider class to here. And we're going to say, create user is just a method, takes the request. Incidentally, if it matches up by name. You also get the request object itself magically if you ask for it. Again, exactly the same in Drupal 8. That's the exact same code we saw before. Get user, it's a lot thinner. Why is that so much thinner? We're now going to, in the application, register a service controller service provider, which does black magic behind the scenes, which lets us register controllers as a service name. So I'm going to register that user controller class as a service, and then tell it users.controller, which is the service name, :create user. So when you go to route this request, load up that service, however you're going to do that, and then call that method on it. That syntax is standard to Symfony and is supported in Drupal 8 as well. Although in Drupal 8 we don't recommend you do full-on service controllers like this. There are other options. For more information on that, see my talk Drupal 8 crash course, which I'm not giving here. It is available online. There's several videos of it. Or come to DrupalCon LA, where I'll be giving it as well. So this gets a lot thinner. So controllers post. You can post to /users. You call that method, and that's the name for it. If you send a get to user/user, that's the service, that's the method name, that's the name for it. And we're going to also tack on this conversion logic. So we're going to say for something, whatever comes in at user, call this closure on it, and whatever it returns, use that instead. This allows us to say, all right, we've got a username. Let's just load that object, the user object, out of our system and return that. One line of code, and now our controller is a lot thinner because it doesn't have to deal with loading from the database. We've separated that concern out from our controller, and now our controller is dead simple. This is a good thing.
What is the bind user's view?
Bind? That's where you tell it this is the machine name to use for this route.
And is that machine name used elsewhere?
If we wanted to link to it, yes, so that in the post code, let's look at that again. Yeah, right there.
But is there a place where you assign that to a specific piece of code? Is that where you're assigning?
That bind method is saying this arbitrary string will be the name of this route because I so decree.
And when you do the generate, you're saying, all right, I'm defining the route.
No, the generate is, given there is a route named users.view, take its path.
Sure.
It has a placeholder called users in it. Swap this string in for that, just like you were calling a T function in Drupal.
Right. But there is a place in the code where you're defining user.view?
Yep, that's the last screen we were just on. Where was it? User.view, right there.
Oh, okay.
That's the extent of it. That's the only two places user.view appear.
That's the source of my confusion.
Yeah.
And also, when you're doing dash post and dash get,
Mm-hmm.
is that a part of Silex?
Yeah, that's Silex code.
Okay.
Okay. You can also add a put method. Looks very similar. We're going to put, give that a name, run the same conversion code, and then our actual controller for that just take the content from the request. We've got the user object, so you know what we're updating. Override the username and age from the object that was posted to us. Save it, and return whatever get would have gotten us. Whatever. When you put, actually REST semantics don't say technically you have to, what you have to return in that case. In this case, I'm saying when you put, you will then get back whatever you would get if you were to send a GET request immediately, because I like doing it that way.
Could you do a 201 redirect to the get?
No, because 201 means created, and we did not just create an object, we updated an object. But you could send a 300 something redirect if you wanted to. Be kind of silly, but you can.
Could you use put to create Crell the user?
You can, semantically, you can use put to create Crell the user if you know the URI that it's going to live at. In this case, I didn't set it up that way. REST, you have choice in that regard. At this, all right.
Well, Larry, if you change the username, then
This is true. If I change the username, then this would break a little.
user.
All right. So now let's do the same thing for messages. We're going to add another pseudo modularly type thing. We've got a repository. I'm not going to show it. It's the exact same thing as users, just with a different table. We've got a messages controller. So we can create a message, and we can retrieve a message. And we can also reply to messages, because that's kind of important. If you're replicating Twitter, you need to be able to reply to people. So in this case, let's actually look at how we're going to wire that in. So very similar, /messages is our index of messages and where we go to create one. Messages /message ID, it's a message ID, I think, is an individual message. And we can also apply where we can post to that URI to post a reply to it. At this point, we're talking REST logic. I'm just using Silex syntax to do standard RESty stuff, which is where Silex really shines, because there's 4 lines, 5 lines to wire all this stuff up the way REST should be used. That's nice. That's where it gets out of your way very quickly. And it's still messages controller. You can give the machine name. Same upcasting logic we saw before. Nothing particularly exciting here. And then, service provider we've already seen, controller we've already seen. Let's try actually doing it. So if we post to messages, text of assuming I typed all of that correctly, should get a 201. Here's a location. If we now go to messages 1, you can see the object, message, the author, the parent. We'll fix that in a moment. And if we want to reply to it,
Parent would then be 1, right?
what's that?
The parent would change with the reply, right?
The message we have, its parent is always 0 because it doesn't have a parent.
Right.
Our new one, if we look at it, yep, message is 2, so to get to there,
Nice.
there's our author and our parent. So are we done? Well, almost. Still more features of Silex I want to talk about. For example, error handling, because so far everything's worked great. Live demos. How often does that actually happen in production?
Never.
Never, right. So we need to handle errors. So, let's talk about listeners. Listeners are essentially, events. They're the Symfony event system, similar to hooks in Drupal. Drupal 8 includes both hooks and Symfony events. Sorry. In this case, there's just nice utilities in Silex to wire them up very easily. You can call app error, give it the name of, and then give it your handler, which again is a closure. In this case, we're going to say, if we get an exception thrown, because most errors are going to be exceptions in modern code, then run this code. But if it's an object not found exception, this code gets run first. It will actually match in the priority, the second parameters are priority, high number wins, and check the object type. And say, all right, if there's an object not found error, do this. If it's a not found exception, do this. Else we didn't get anything else, or just send a generic. What's our error handling? This is also a class on REST, if you hadn't noticed. There is no standard way of sending an error message in REST, but there's 2 common formats, API problem and VND error. I like using API problem because when I needed to choose between the 2, it was a little bit easier to work with, and so I wrote a library to help format it. It's, again, just a JSON string. So we're going to pull that in via Composer, because everything's on Composer. And so in this case, we've got, if an object not found exception is created, we do our handling. We create a problem object, render to JSON, and send a JSON response. We just pass on the error message. If it's a not found, same thing. We can specify what our HTTP response code is going to be. If we don't specify, it's 500, I believe. Yeah. And now, any exception that gets thrown and bubbles all the way up to this level will get caught by one of these, and we'll get the right response object coming back. You look confused.
Yeah. I'm wondering if API problem, JSON, response, is there any reason to not have those come through dependency injection?
The object instances, you mean?
Yeah.
These are not services. These are data objects that have no logic to them other than standardizing the data structure itself. So these are okay to instantiate on the fly. Just like you'd create a response object in a controller. That's legit. Mm-hmm. That's totally okay.
Well, what if, my understanding of service containers is that there may be a reason in the future that you need to change something about API problem, but you can't change this code. So you hope API problem comes into the service container so that you can change it there.
You certainly could if API problem doesn't have a factory service. Mm-hmm. If there were one, you could register that in your container, and then access that and say, all right, give me an API problem for this type of thing. That becomes a case-by-case architectural question. For something this basic that has no logic to it, it's just a data object, I'm fine doing it directly, because if the logic changes, it's probably because I'm changing something here.
Okay.
There probably is an argument to be made to the contrary, but this is the typical pattern that I've seen.
Okay.
And this is both valid in Drupal 8 as well. Create response objects yourself. That's something it is safe to call new on.
Okay.
In addition to error, there's a couple of other events. Most notably before and after. Symfony people in the room, before is the Symfony request event, after is the Symfony response event. Drupal people in the room think hook request alter, hook response alter. That's basically the mental model. For that, I'm going to register a few more. So let's talk about what we're actually doing with our content, because we don't want to send hypermedia. We want to be properly RESTful, which means we want to send back hypermedia links, which we're not doing right now. We're just sending back JSON blobs. So we're going to use a nice, simple format called HAL, Hypertext Application Language, because that's the format being used by Drupal 8 and by Zendapp Agility and most other things at this point. It's a very nice, simple format. We also, therefore, want to keep track of the request format that's coming in. So we need to do content negotiation. How do you do content negotiation? This is a hard problem space, but the Silex part of it is easy. We register a listener called with before. So before means somewhere before the controller, this code gets called. And it's going to get the request that's coming in and the application. And we're going to do some very simple content negotiation on the incoming request, i.e. look at the accept header that's coming in and say, all right, these are the formats that we're allowed to get by MIME type that the browser is willing to accept or the client's willing to accept. Let's figure out which one we're using. This is very simple, stupid, naive content negotiation that does not take into account the full spec, but it works well enough for a client that is not a browser. Browsers send broken headers. Browsers are terrible about HTTP. If you're writing your own client, then you can be not stupid about it. And then this would work. In this case, this is just standard Symfony code. I need to speed up a little bit. So get a list of the content types that are in the accept header, see which one we actually can support, and set that as the request format on the request. Again, hook request alter, basically. And then I'm also going, in the controller, let's show that first. Instead of just returning the object right out of the database, we can create a HAL object using another library called nocarrier_HAL. It's just a plain PHP library up on packages available through Composer. Notice a pattern emerging. Silex has very little implied overhead, which means random package on Composer is a module for you. So we're just going to pull that in, create a URL just like we saw before. That's the self link for it. Add a link to the author of the message. If there's a parent, we'll link to that. All we're doing here is creating a link, a URL with the generator, and shoving that onto that object. And then strip off all of the data we've just converted to links. And then we return that HAL object itself. So that's not a response object, and it's not a string. So how does Silex know what to do with it? Silex doesn't know what HAL objects are. So we're going to tell it. With a view listener. This, again, is part of the standard Symfony pipeline. This is present in Drupal 8 as well. There is unfortunately no utility method for it, so we're going to do it the clunky way. And we get the controller result out of the event that gets passed to us, which is whatever got returned from the the controller, whatever that is. And if it's a HAL object, we know what to do with it, which is we're going to convert it to a response. The job of a view listener is to take whatever that thing is and turn it into a response object, because that's the only thing the Symfony kernel knows what to do with. And so if it's a HAL object, and the request format is either, it's small here, yeah, the request format is JSON or HAL JSON, then we will just create a response object out of that. This HAL JSON response is just a class that wraps up taking that object and calling the serialize on it, basically. If it's, and then that response gets set on the event, and we're done. But what if the accept header was wrong? Well, if we're in debug mode, remember that app debug we defined in our environment before, then we'll load it through as application JSON. Why application JSON instead of HAL JSON? Because it's a different MIME type. Because if you're in your browser and just throwing requests from your browser window at the service, and what comes back as application JSON, it'll display it as a string. If it comes back as application HAL JSON, it doesn't know what to do with it and will tell you to download it. This is less useful. So this means in debug mode, we'll just ignore it and let you return a JSON string. You can use your browser for debugging. In production mode, debug is off, and so we'll just prevent that. You have to have the correct header. Nice simple toggle. And in neither case, throw an exception, not acceptable HTTP, part of Symfony, also available in Drupal. And then there's already listeners that'll handle that and send the correct 406, 415, I forget what the error is. You don't even have to think about it, it takes care of it for you. Then we set the response object we just created, and that gets sent off. So what does that look like? Oops. What's that? 2 minutes. I'll talk very fast. There's a break after this anyway. So here's our message, and now here's our links. So a truly RESTful client can just traverse those links to get to the parent message or to a user or whatever. One last thing. If you're building something on the web, you care about caching. You care about caching because otherwise your app is slow and no one likes you. I said there's a before and an after. Come on. Just gonna. This is the simplest HTTP caching you can imagine. We call after, meaning hook response alter, basically. And if we're in debug mode, then just return. We're not going to do any caching. In debug mode, caching is off because it makes debugging really hard. If we're not in debug mode, all right. We have a cache lifetime property that we set in our container, i.e. we set in our config file. And that's in seconds, and then default to 0. And then, all right, response, set the time to live, and set the client time to live. HTTP caching is really powerful. It is also really, really annoying because it is so complicated. And Symfony's response object normalizes all of that for you. It's really nice because there's 2 different ways to set cache expiration logic in HTTP, and one sometimes works and the other sometimes works. Yeah, I know. It's really powerful when it works. So we're just going to say, the time to live for both proxies in the middle and the end browser or end client are the same. We're going to set the expires header to be now plus however many seconds later. And we're going to set an e-tag. An e-tag is a unique identifier of the content. This is part of HTTP caching, which if that changes, then you know the content has changed and you need to re-request it. It'd be nice if we could do this before we run through the request and know, okay, this object has changed or not, except we've got links, so a different object changing could affect this object. So we could build a fancy system to do cache invalidation across objects like that, which is what, say, Drupal 8 does. I'm not going to bother. I'm just going to going to get a hash of what I'm about to send back, set that as the E tag, and then ask Symfony, so given everything I've just told you, should I send back an HTTP 304, meaning you've already got the data, don't ask me again, and I'm sending back no data? If so, do so. Here's your caching. Again, this code here is just general Symfony. This works in Symfony, Silex, Drupal, whatever. We're doing something a bit more elaborate in Drupal, but it's essentially the same process in Drupal 8. And now, if a client hits the system and it sends an E tag along saying if the SHA-1 code is ABC123, then I've already got that, so don't bother sending it again. So we'll get to this point, say, all right, so change the request, send back a 304, not modified, saying you've already got it. The client says, cool, peace out, and we're done. And we haven't sent anything on the wire other than a couple of headers. This is good. And that is the major parts of Silex. Thank you.